All right, so we are here live at AWS reInvent. I am Zoe Steinkamp. I'm a developer advocate for InfluxData, and this is my coworker Jay, also a developer advocate. And today we're going to be talking about unlimited cardinality, but first things first, we need to know what cardinality is. So Jay, would you like to tell us?
Yeah, thank you for having me, Zoe. So when we talk about cardinality, we like to do it with an example to keep things like holistically interesting. So the idea here is, let's imagine we had, say, 1,000 households, and we wanted to monitor the temperature of these households. In order to be able to differentiate each house from one another, we'll have to have metadata to do this. So let's say we have a tag called House ID. Each of these House IDs would be unique. So we'd have 1,000 different House ID tags. So this is all well and good. It allows us to independently monitor each household and store the temperature for each household in our time series database. But what happens if we say scale to 1 million households or 10 million households? The number of this index increases indefinitely. And this is a problem for an index-based time series database, because we need to store this index in memory. So we need to indefinitely increase the size of our memory to be able to keep all of these indexes in memory at the same time.
I see. So I feel like we're getting a little bit closer then to the next question of unlimited cardinality, because as you're talking about scaling. So can you go ahead and start to explain where unlimited cardinality really comes into play and becomes a problem somewhat?
Yeah, absolutely. So we've kind of talked about it a little bit there. We have 1 million households all trying to independently write data to this time series database. What happens is the impact is your query times, your overall memory CPU usage when using the time series database. And in the end, the time series database will just fall over because you don't have the resources required to handle that level of cardinality. So the idea now is, what we wanted to do is develop a time series database that has the ability to deliver unlimited cardinality. So essentially be able to remove that gap, being able to produce indefinite tag values for that data.
All right, that makes a lot of sense. And I'm assuming that this new DB you're talking about is InfluxDB 3.0. So why don't you explain a little bit about how InfluxDB 3.0 allows unlimited cardinality now?
Correct. So what we've done is we've actually removed this service called the TSI. So the TSI index is what used to formulate and keep track of all of our independent tag values. What we've now done is we use this format in Parquet, as well as this meta database to formulate a way of storing in a columnar format all of your tags without the need of keeping an index in memory, which makes it highly performant for storing high cardinality data without any of the drawbacks in terms of memory usage, resource consumption, and so forth.
Can you give me one example of a good high cardinality data set?
Yeah, of course. So the observability use case is critical here. So we got to think traces and span IDs can be indefinite. You will have so many different independent trace IDs and span IDs that spawn. I mean, we have customers in the millions, if not billions, of these unique trace IDs and span IDs. And this is in itself one of the main reasons why we developed 3.0 to handle that high cardinality data.
That makes a lot of sense. Well, Jay, thank you so much for explaining why cardinality, and especially unlimited cardinality, is so important for people working with the time series database. If any of you guys are working on anything with InfluxDB 3.0, please give us a shout and let us know what you're doing.